Hello everyone, welcome to Engineering Xplained channel. In this session, I am going to explain the surface tension. The surface tension is one of the property of the fluid in the fluid mechanics. And about this surface tension, its definition, its units, and how that surface tension acts on the fluid, that I am going to discuss in this session. First, we'll take the definition of surface tension. Surface tension is defined as the tensile force tensile force acting on the surface of the liquid in contact with gas or on the surface between two immiscible liquids, such that the contact surface behaves like a membrane under tension. Okay, here at the free surface of the liquid, where the surrounding air has a gas which comes contact with that one at that surface, and if there are two liquids are there, where those liquids are comes contact at that surface, there is a tensile force is acting, and that tensile force we will call as a surface tension. And how it will be there and how that tensile force acts will explain further. And first we'll take that what is the cause for the surface tension. The force of cohesion is the cause of surface tension at the free surface. And cohesion means it is intermolecular attraction between molecules of the same liquid. It enables liquid to resist a small amount of tensile stress. Cohesion is a tendency of the liquid to remain as one assemblage of the particles. Surface tension is due to cohesion between the particles at the free surface. The cohesion means there is a cohesive force, that is a cohesive force will be acting, and that cohesive force what will be acts due to the molecules of the same liquid, that is the cohesion force, and that cohesion force is cause for the surface tension. Here this is sketch can be taken for the explanation of the surface tension. Here we will consider the three molecules, molecule A, B and C. The molecule A is inside the liquid, and as the molecule A is surrounded by molecules, and those molecules are attract this molecule, there is a attraction force is acting on the molecule A, and that is called as the intermolecular attraction. And here the whatever the force acting on the molecule A, which is equally attracted by all the molecules surrounded by it, the resultant net force will be 0, and therefore this molecule will not experience any force. The molecule which B, which is nearer to the free surface, and in the downward direction all molecules are attracting this molecule, and in the upward surface, upper surface, there is no molecule here. There is no molecule, there is no force of attraction at the surface. Due to that, there is an unbalanced resultant force act on the molecule B, which will be in the downward direction. And that net downward direction force was what it is acting, that is the tensile force. That is the tensile force. Similarly, the molecule C, which is at the surface, and on that also there is no upward force is acting on the molecule. There is a net resultant downward force is acting on the molecule C, which will be experiences tensile force in the downward direction. Therefore, here all the molecules which are at the surface of the liquid, which are in contact with the surrounding gas or air, and those will be experiencing a tensile force in the downward direction. The tensile force acting on the molecules which are at the surface, and that tensile force is called as a surface tension. Okay, that is the surface tension, how it will be acting at the surface of the liquid. If it is not a free surface, then another fluid if it is there, then there also the same liquid molecules are not present at the surface, and thereby there also there is a surface tension acts, but for the common definition we are going to take as a free surface only. Okay, further moving here, it is denoted by a symbol sigma, and its unit is Newton per meter, that is force per length. Then dimension of surface tension we can take, as we know that surface tension is given by the formula surface tension is equal to force per length. We know that force is equal to mass into acceleration. Substituting value in the equation, we get surface tension equal to ma by L. And then equating the fundamental quantities into the equation. Here, the fundamental quantity we get, there is a mass, the fundamental quantity is m, and acceleration. What is their acceleration? It is a meter per second square. Meter per second square, that is meter length we have taken for the distance. Second square, the time, it is a per unit time it is there. That is L t raised to minus 2 we are going to get. And there is a L in the denominator that will be comes in the numerator as a L raised to minus 1. After simplifying this one, after simplifying, we are going to get the solving further. We are going to get that is mt raised to minus 2. Hence, the dimensional formula of the surface tension is mt raised to minus 2. And here, the surface tension, which is to be calculated for the solid sphere, hollow sphere, and the hollow vertical tube. In the next session, I am going to uh, take them, derive the expression for them, that is surface tension for the solid sphere and hollow sphere as well as the vertical tube, and that expression is used for the calculation of the surface tension of the different surfaces. Thanks for watching Engineering Explained channel. If you like, share, subscribe and comment.